All right, thank you for having your bell work, or not, sorry, your notes ready to go. Thank you, thank you. All right, today we are using exponents to expand and condense expressions. And if you understand what an exponent does and how you just write it out, we expand it, we make it bigger. That's the best way to learn exponents. When I'm teaching, we do this in pre-cal. I still go back to what does it mean when we have these exponents. And so, exponents. In the case of repeated multiplication with the same number, we can rewrite the expression using exponents. All right, so for example, 4 times 4 times 4 can be written 4 with an exponent of 3. Very good. So that 3 tells us to repeat the base that many times. So for instance, here I have a little generic little notation here. This is x to the nth exponent, okay? X is called the base. And n is called the exponent. E-X-P-O-N-E-N-T, exponent. And we read that as x to the nth power. X to the nth power. That exponent just tells you how many times to write out the base using multiplication. And that's what an exponent is. It's just repeated multiplication. And so you can do this if you want. We're going to go through, I'm going to do all of them today because it's like quite easy. And it'll go quite fast. So we are going to write each expression using exponents and evaluate, if possible, is the key. Some of them we cannot evaluate, okay? So here it is written out, 11 times 11. How would I write that using exponents? Same as. Oh, 11 to the second. Oh, number 2. Okay. 11 to the second power. I knew that's what you meant to say. So this is 11 repeated 2 times. All right. That's what that power means. Repeat the base 2 times. All right. And what is 11 times 11? 121. So we can figure out the value when we're looking just at numbers. All right. Here, what's our base going to be? 2, lots of 2's here. How many times is that 2 being repeated? 1, 2, 3, 4, 5, 6, 7, 7. It's being repeated 7 times. Ladies and gentlemen, what is 2 to the 7th? 128 is right. Okay, I maybe didn't know. I maybe didn't know that it was 128. And so in our calculators, this is something a calculator is good at. Could I write 2 times 2 times 2 times 2 times 2 times 2 7 times? I could do that? Yeah, I could. Or I could do 2, and this little button right here above the division, that is exponent. So it's called a caret, and that caret moves you up into exponent territory. A superscript is what that's called. And so then you can type in 2 caret 7. And then evaluate, we get 128. Did you know that button was a caret? And did you know that that's how you got exponents? Okay, now you do if you didn't. Okay, great. All right, ladies and gentlemen, number 3, what is the base? -5. You'll notice I put it in parentheses. I'm going to keep it in parentheses. It's very, very important. -5 is being repeated. How many times is it being repeated? 4 times. Now, we're going to put this into our calculator. Should you use the parentheses? Absolutely. We should use the parentheses. So parentheses, -5 caret to the 4th power. Is this going to give us a positive or negative result, do you think? Positive. How do you know it's going to give you a positive result? Okay, so we've got negative times negative, that's going to give you a positive, and over here we've got negative times negative, and that's going to give you a positive. It's all going to be positive. Yeah, if there's an even number of negative signs, we're always going to get a positive result. Okay, what is -5 quantity to the 4th? 625. All right. So I have a question for you, and we're going to do this on the side here. Hello. Go ahead.
Anyone who's any
8th
graders that are dressed up, raise your hand.
8th graders dressed up.
And then any 7th graders that are dressed up, raise your hand. Okay, thank you.
Thank you. All right. So, on the side here, what is the difference if I wrote -5 to the 4th? What's the difference between what we did here on number 3 and what's this? No parentheses is a very big difference here. If I were to expand this, I have to ask the question here, really important. What is being repeated? Just the 5, it turns out. That exponent is closest to only the 5. That negative is hanging out in front. So what this is saying is the 4 is saying repeat the 5 4 times, and that negative is just coming along for the ride. Here, the 4 is touching the parentheses. It's closest to the parentheses, so it's saying repeat everything inside the parentheses 4 times. Do you see the difference? One answer gives us positive 625. What does this answer give us? Negative 625, because only the 5 is being repeated. If you guys understand this year, all of math is so much easier. Does that make sense to you? Okay, excellent. All right, what is my base on number 4? 1/4. All right, is my base, how many times is it being repeated? 3 times. Good. And so we can put this in our calculator. I can do parenthesis 1 divided by 3. So you should all try this along with me, okay? Just to make sure you're putting it in correctly. Oh, that's supposed to be a 4. Sorry, 1 divided by 4. And then caret to the 3rd power. All right, and what do we get? Ooh, crazy decimal. What can we do? Math frac. We get 1/64. Thanks for grabbing calculators, guys. Always, always, you want to follow along with the calculator. All right. 4 times 4 times 4 is 64. We are just multiplying fractions. 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. Straight across, okay? Number 5. Let's condense this. I have a base of 7 repeated how many times? 7 repeated 2 times. And then I also have a base of 4. How many times is the 4 being repeated? 3 times. Good. So we can condense that instead of having it all expanded. All right. And if I want to plug this into my calculator now, I'm going to do 7 caret 2 and then times 4 caret 3, 4 to the 3rd power. All right. Make sure you don't get everything up in the exponent. All right. You have to get out of the exponent land. Okay. All right, what is that? 3136. Crazy. Okay. You could also double check, did I do it right? 7 times 7 times 4 times 4 times 4. We should get the same thing, shouldn't we?
Yeah.
3136. Okay. So you can absolutely check both. Always a good thing. All right, let's look at number 6 here. What's one of my bases?
8.
8. All right, 8 is repeated how many times? 4 times. 1, 2, 3, 4. Okay. And then what's my other base? -2. Notice the parentheses there. I want to keep those in there. How many times is -2 being repeated? 3 times. Very good. So again, I can evaluate this because it's all just numbers. So 8 caret 4, arrow out of the exponent there, and then times -2 to the third power. Oh, so you do have to be careful. The negative is down here, not subtraction. Okay, good. Awesome. All right. So we get, for our evaluation, -32768. Is negative correct? Should this answer be negative?
Yep.
Why? When we count up how many negatives are written out here, we have an odd number. 2 of them make a positive, and then times another negative is going to give us a negative result. So there's an odd number of negatives. We're going to get a negative answer. Okay. All right. Let's look at number 7. What's one of my bases? 2/3. Okay. To what power? To the second. And then we have another base. What's the other base? 9 to the second. And again, if we type this into our calculators, we get 2 divided by 3 to the second power. And then times 9 to the second power. And I get 36. All of these on 1 through 7 were all just numbers. So we could actually find a value, an actual number answer. Okay? But now we're getting into algebra land. A isn't a number. Can we evaluate that? Can we give a number answer? No, I don't know. I don't know what A is. It's something weird. All right, so my base is A. How many times has it been repeated? 9. All right. And we cannot find a value on that one. All right, what's my base on number 9? XY. I'm going to do XY, and I'm going to put that whole thing in parentheses. How many times is the XY being repeated? 5. 1, 2, 3, 4, 5 times. And again, that one cannot be repeated. Try the next. Hello? Okay. All right. Bye. Stevie, we'll go to the office. You got a doctor appointment. All right. This is not the only way to write this one. Do you understand why I put parentheses around it?
Yeah.
Why did I put parentheses around?
It was for XY, not just Y.
Good. XY, not just Y. Very good. Do you suppose it would also have been okay to write X to the 5th times Y to the 5th?
Yeah.
Yeah, that works as well. Either of these answers is great. We have X repeated 5 times, and we have Y is repeated 5 times. So that works as well. And in fact, they mean the same thing. Okay. All right, we have a couple of letters here on number 10. What's the first letter you want to use? R. R to what power?
Second.
R to the second. Times?
S to the 5th.
S to the 5th. Times?
T to the 3rd.
T to the 3rd. Can I evaluate it? No. All right. Number 11. What do you want to start with?
K.
K. So normally I'm going to say we start with numbers when we have a mixture of numbers and letters. So let's start with the numbers first. So we have a number 9 repeated how many times? 3 times. And then we have the letter K repeated how many times? 6 times. Very good. What can we evaluate here? Yeah, we can evaluate that number, 9 to the 3rd power. So 9 to the 3rd power, 9 times 9 times 9, is 729 times K to the 6th. So anything that has numbers, we can evaluate. If it has letters, we just leave it. All right, number 12, what do you want to start with? -7, and it's in parentheses because I want that negative, the whole thing, to be repeated 2 times. And then what letter next? M, how many times? 3 repeats. And then N, 2 times. N repeated twice. So -7 times -7 is +49. M cubed N squared. All right, 13 and 14 are very special. On number 13, what's being repeated? P minus 2. All right, pluses and minuses work very differently here. How many times are we repeating P minus 2? 3 times, and that one cannot be evaluated. Addition and subtraction work very, very differently. So we just leave all those with addition or subtraction in them. All right, and number 14, what number is being repeated? 6. How many times? 3. And then we have A plus B repeated how many times? 2 times. So here, can I evaluate that 6 cubed? Yeah. 6 times 6 times 6 is 216. And then we have A plus B, quantity squared. All right. Questions on those? That's pretty easy, right? Oh, sorry, yeah. All right, turn to the page. Probably. How much time is gone? Okay. All right. So 0 exponent has a very special rule. Any number except 0 raised to the 0 power is defined as 1. Always, always. Any number to a power of 0 equals 1. 2 to a power of 0 equals 1. 3 to a power of 0 equals 1. 4 to a power of 0 equals 1. Any x value, any number raised to a power of 0 equals 1. 734 to a power of 0 equals 1. Any power of 0 always equals 1. Okay, it's just the rule. All right. Now, if we know that we have a 0 exponent, then we also have a negative exponent rule. And this is any number with a negative exponent. So that number has just got a negative in front of it. Means that it wants to trade places. It wants to flip down into a denominator. I like to think about it as a happy, sad exponent. All right? Right now, this exponent is sad. He's negative and sad. He doesn't like being up high in the numerator, and so he wants to transition over down here to the denominator. And once they move into a denominator, now, is it negative anymore? No, it's happy. He's now in a more happy space. All right? So, when we look here, we want to write the expression using positive exponents and then evaluate if we can. Right now, is my exponent happy or sad? He's very sad. And because he's sad right now because he's upstairs in the numerator, where does he want to go? Downstairs to a denominator. So we go 1 over, now 5 to the happy 2. When you move it downstairs, it becomes happy. And so this becomes 1 over, what is 5 squared? 25. 5 times 5 is 25. So we get 1 over 25. Let's look at number 16. Is that a happy or sad exponent? Sad. And it's sad, and he wants to go downstairs. So we're going to go 1 over 8 to the now happy power. Happy power 2. And so we have a 1 on top. And what is 8 squared? 8 times 8 is 64. Good. In the denominator. Let's look at number 17. Happy or sad? Sad. Where does he want to go? Downstairs. So it becomes a 1 on top and a 9 to the now happy 1 on the denominator. What is 9 to the first power? Just a 9. It's repeated 1 time. That's all it is. 1/9. How do you feel about that? Is that okay? Yeah. Happy, sad math? That's how we work? Let's look at number 22. Now I see a bunch of things here. I have a 5 to the negative 4. Happy or sad? Sad. Sad. He wants to go? Downstairs. So it becomes 1 over 5 to the happy 4. On number 22? And here I have a 3 to the negative 2 power. Happy or sad? Sad. Also sad. So that also wants to go downstairs. So we have 1 over 3 to the happy 2 now. And now it's fractions, right? Yeah. So we have, on the top here, I have, well, I'll just do it this way. 1 over, what is 5 to the 4th? I don't know. 5 to the 4th, 625. So 5 to the 4th is 625. And then I have 1 over, what is 3 squared? 9. 3 times 3 is 9. All right. And now we are multiplying fractions. How do you multiply fractions? Straight across. 1 times 1 is 1. And now we, in our calculator, 625 times 9 is 5625. Very good. Straight across, multiplying fractions. All coming together. All right, let's look at 24. I have 8 to the negative 3. Happy or sad? Sad. All right. So that one wants to go downstairs. So what does it turn into? 1 over 8 to the happy 3rd power. What about 10 squared? Happy or sad? Happy. Happy. He's perfectly happy up here in a numerator. So that one's just going to stay. And what about 4 to the 0? What is that? It's just 1 every single time. Anything to a power 0 always equals 1. So now we have fractions being multiplied, and I just get to multiply straight across. 1 times, what's 10 squared? 100 times 1. What do we get in the numerator? 100. And then we have 8 cubed times 1. What is 8 cubed? 512. All right. 8 cubed is 512. Very good. And what do we need to do with this fraction? Math bracket. Very good. So 100 divided by 512. And math bracket, we get 25 over 128. Very good. Question so far? 2 more. We're almost done here. A to the negative 4. Happy or sad? Sad. Sad. So we want to go downstairs to a denominator. It's going to become 1 over what? A to the positive 4. Very good. It moves. It's now a positive exponent. And this cannot be evaluated any further. That's all done. Okay? All right, let's look at 28. I have 3 to the negative 3. Happy or sad? Sad. So that becomes 1 over 3 to the happy 3 power. There we go. All right. What about m to the negative 4? Happy or sad? Sad. And so that wants to go 1 over m to the happy 4 now. Don't you love happy, sad math? It makes it so easy, doesn't it? All right. What about n to the 5th?
Happy.
Happy. N to the 5th is perfectly happy upstairs in that numerator. All right. So that one's going to stay up in the numerator. Now, what do I have in my numerators when I multiply straight across? N to the 5th. 1 times 1 is 1, times n to the 5th is, maybe we could write 1 n to the 5th if we wanted to. In my denominator, I have a 3 cubed. What is 3 cubed?
27.
27, very good. 3 times 3 times 3 is 27. Times m to the 4th, times 1. So that's just the same thing, times by 1. All right, there we go. 1 n to the 5th over 27 m to the 4th. Crazy. Good job, you guys. Do you have questions for me? Way to go. All right. Today, you have 2 options. You have a